So we're gonna rinse out the burettes or whatever they're called, and then do the acid stuff, and then take the pH of the acid, and then you guys need to find the H plus, and you would do inverse log of negative the pH to find the H plus.
Someone want to have the graph out and like put in the numbers.
Wait, say that again.
Like, you know how we're supposed to do the graph? Someone want to
I don't know. You're supposed to plug You're supposed to plug in the pH and then the milliliters, I think, but just pull up the graph. We're not doing that yet, so don't worry about it.
Yeah. Well, I'm gonna make someone. I don't know if I should.
I can try and make a graph on the on sheets and share it with you guys.
No, he has a graph. You just need to put the thing in. You just need to make a copy and share it with all of us.
Okay, I'll share it.
Yeah, thank you.
FYI, the molarity of the the base, is 0.130.
Is the base the HCl or the NaOH?
What?
The base is the NaOH because it has the OH.
Oh, okay. And she said it was 0.13, right?
Yeah.
Okay, I shared it with you all. It's called Titration Curve Room 1.
Okay, we rinsed everything out, and now we're gonna pour the acid into the burette, and then pour it into the beaker, and then put the bifolumine or whatever into it for the indicator, and then take the pH of that. Okay, so the pH of the acid without the indicator, I don't know why I thought I needed to put the indicator in there, is 0.99. And you don't put that in the graph, but that's on this part where you put the H plus of it, you find that by inverse log negative of 0.99.
What do we end up with?
Wait, so the pH, I think it's 0.102, because I did the 10 to the negative 0.99, and that's what I got. But I don't know if I did that right. So
Sorry, what did you get?
0.102. But you said right. You said take the 0.99 and do the 10 to the power of like the negative 0.99. Okay, so yeah, that's right then.
0.102? Okay. Okay, now using that information, you guys need to find the milliliter of base that needs to be needed or that needs to be used. I think you do mava like ka equals, you know what I mean? I'm not sure.
Wait, I thought we used that to find like the molarity or
Okay, that's 10 milliliters. So then we add 4 drops of this.
Do we add the 4 drops to these or?
You don't want to pollute these with the indicators.
So there's a color change right there.
Yep. Whoa, what are you doing? 4 drops?
I thought it was like 4 whole
No,
things.
no drops.
So
All right.
redo.
And we'll see. We
Okay.
can use this as a test trial.
And then I add.
Let's put the caps back on stuff. That way, if we knock it over, it doesn't spill all over, right?
Yeah. Okay, and then don't I take the initial volume of this?
You should have taken the initial volume already.
But it was at 0.
Right, so the initial volume is 0.0.
Okay, so the initial volume of the acid was 0.0 FYI, and then the initial volume of the base was also 0.0.
Oh, I don't know about that one.
0.01.
No, it looks too high. It looks above the 0. So we can't actually measure it.
You guys determine how much base. Oh, Gavin determined how much base we need. There we go. How did you do that? We give them the pH.
Okay, that looks 0.99.
0.99. All right.
Okay, and then the initial volume of
No,
the
no,
base.
no. 0.99. It's like 0.19. Maybe. Each of these is 0.1. That's why this instrument's so expensive.
Okay.
This
So-
would right down here would be 0.99, almost to the 1.
Oh, okay.
Right?
So 0.19. Okay. So the initial volume of the base is 0.19.
We're supposed to find how many milliliters are needed.
Did they do that yet? Did you do that?
So that was what we were supposed to fill in for 6.
You know the malaria.
For no, it wasn't. For 6, you're supposed to find the milliliter of the base that I need to stop at.
Oh, okay. Wait. So what was 5? Like pH equals.
0.99.
Oh, and then we calculate the H.
Yeah.
When it says initial volume, that's for, yeah, I don't know.
Okay, so now.
And that's before we put down milliliters.
Wait, now I'm confused. Can you like say what we were supposed to do?
No, I'm confused too. So I don't know how to help.
For the H plus, I got 1.02.
Yeah, that's what we got.
Okay.
Okay, so now that we put 4 drops, we found that. So you guys need to find number 6. I'm sorry, I don't know how. He said ma, va over ka, that stuff.
How do we find how much milliliters of base? Yeah.
Use the pH to find the hydrogen ion concentration and use MAVA over Ka to find the molarity of the base. I'm sorry, find the volume of the base.
Did you just hear that?
So what do we need to give?
You need to give the pH and the molarity of the acid.
Did you guys hear that?
I'm sorry, the molarity of the base and the volume of the acid.
No, what did you say?
Okay, he said that you need to find, we found the H plus, and then you use that to find the volume of the base. So I don't know how you get from H plus to molarity. I don't know if it's the
Oh,
molarity.
okay. So the molarity, I think Raylan asked this. You need the pH, and then you do that like thing where you do 10 to the negative power, and then
No,
that.
we already did that.
I know, but this is how you need it for the MAVA, because the MAVA asks for the molarity of the acid, and H plus is the acid. Like H3O plus is just H plus, and this when we use that pH, we use that to find the pH of our acid, the molarity of our acid.
Okay, well, find it because I need to. When you guys find it, just let me know because then that's when I can start doing the base thing. Wait, so Mr. Jackson, how do we get from H plus to molarity?
H plus is the molarity of the acid.
Okay.
Because it's a strong acid.
Okay, so H plus is the molarity of the acid. So we do H
That's
plus.
yeah. What we need to know is how many milliliters of the acid did you put in?
It's the initial volume.
Yeah, no. What is the initial volume, of the acid?
0.
And what's the final volume?
10.
So we need to put 10 to know how much base. In the MAVA, we put 10 as the.
The loss of the volume of the acid, yep.
Yeah.
Yeah.
If it is 10. It's like 9.99, but.
Okay, it's 9.99, the final volume of the acid. Okay, so it would be molarity of the acid, which is was it 102? Times, is it just 1 for the Ka?
Yeah, it's 1 for each.
Okay. And then divided by 9.99. Does it make sense now?
Don't we need to know the
No, not
base of the
really.
final volume too in order to do the thingy, right?
We're trying to find the volume, the final volume of the base. That's what we're trying to find. And we know the molarity of the base, which is 1.30. And we know the final, and then we're trying to find the final volume.
So then where do we go?
Hopefully go to step 5 after step 4. So you done this? What's the pH?
Well, we have it.
All right. So is he figuring out the hydrogen ion concentration?
I think so.
All right. Then he should be able to also determine the volume of the base. So then you guys will go to 7. Are you doing the pH meter or not?
What can we do?
Well, all right. Then
Okay, so I got VB equals 0.013, but I don't think I did that right.
Okay. Let me look at my package just in case. So you do.
that's why we use these. That's why they cost $120, guys.
Okay.
You can't tell me you guys are at 0 or 1. You gotta tell me 1.12 or something. We paid $120 for this apparatus. You guys can go out and that's.
Has anyone else gotten it to compare
That's
to
what I
my
mean.
ones?
Like,
I mean, for mine, sorry.
We're wasting the money here if you guys are just gonna go 1.
So, okay, if we use the pH meter later, what would we do?
When you would just titrate it. and go on these different levels. Oh my gosh.
Has anyone else gotten it?
I'm not even gonna lie, like I'm still so freaking confused right now. Like I don't even know what numbers we're using. Like
I'm
I'm
just as confused as you are, but I'm just worried about.
Okay, wait. What's the molarity of the base again? Sorry.
It's 0.130.
I got 7.838.
Hold on, I'm doing it right now.
Okay, because yeah.
Okay, so is it?
Okay, the volume of the acid is 9.99, right?
No, yeah.
Okay, so then yeah, and then CB is 1, and then you divide by Ca, which is 1, and then the molarity of the base, which is 0.130, right?
Yeah. Okay, so I got 7.838
I think we do.
because we do 0.102 times 9.99 divided by 0.130.
I'm gonna round it to 366, so 84.
Okay. So 7.84.
So what equation did you guys use again?
I did VB equals MA VA CB divided by CA MB.
Then you did 0.102 times 9.99 divided by what?
Divided by 0.130 because that's the molarity of the base. I don't know where that number's from though.
and where do we put this answer at? In
Which
the
number?
The molarity of the base, like where did we get that from?
It's on the bottle.
Oh, okay. Thank you.
So there's our MB. What'd you guys get for the MA?
7.83.
No, that's the milliliters needed. The MA is 0.102.
The MA is 1.102.
0.102. All right, so we took that times the 10. So that gives us 1.02. So then we take that and we divide it by 0.130.
We got 7.84.
All right,
They did
good.
9.99.
Yeah,
the
yeah.
value of the
What's
acid.
9.99?
The BA.
Oh, okay, 49.99. All right, cool. So right around then 7, you want to start slowing down. Now you got to determine if you're taking the pH for every time or not, for every 1 milliliter, and then you got to tell them to make sure that they write down the pH that Peter
Should I
said.
just do it for next? The
You
next
can do
one?
it tomorrow or the next trial or whatever, but yeah.
Okay, then I'm not gonna do it this
All
time.
right. So then we just need to add that slowly until it turns blue.
Okay, so I do 2. Wait.
You just do it
I just
slowly
do-
until it turns blue,
Okay.
because you're not stopping at any increments.
I just
Right.
do it slowly. Okay.
Yep. So if you want to get it dripping, and then when you see it start to turn green or blue, then you stop real quick. Or you can go all the way out.
Wait. You said to just let it.
You can, because you know where it should about go, right? So if you want to just let it dump until 7, you can. So let me show you something that's a little bit better, because you're having a lot of trouble there. Let's actually do it this way. There, right? Now you should be able to swirl it and do it.
I'm at 3, so once I get to 7, it should start.
If their math is correct. Do we trust their math?
Okay, it's staying blue a little longer.
So maybe you want to go drop by drop. Can you get it to drop? A little more.
Gavin, we're, oh, wait, what did you say?
Too much.
Oh, no, we weren't bragging about it.
Finicky thing, isn't it?
Where is that? Okay, so we did the first test, but we did not graph.
So we did the volume barely turn blue, or is that like if you guys just go? Yeah, so this is probably not a good one. Is it close to what Gavin found out to be the milliliters? All right. Drop that drop.
And then once it started to like look blue, then we.
There we go. Now get your final volume, and then you can figure out the volume of the base.
Well, the volume of the base is the one.
Okay, it's still kind of.
Can we do the test again?
Go ahead and find the first file. Well, we get the initial base.
Hey,
and then
Ian,
base is
How
drop.
long should it stay blue until we stop dropping?
It just like it
It
just
turns
like
like
goes
a-
black. Like,
Oh,
I don't know,
okay, it
just
turns
turns,
like a
all blue.
Because when it's hitting it,
It should be yellow. Yeah, and then you just, like it'll just start. It'll just be like
They
hard
can tell
blue.
you the volume, you can be like, oh, I'm gonna drop this. Yeah. It's like 2 under that volume as well.
Mr. Jackson, do you do it again?
You do it 3 times, but one of them you actually indicate on with the curve.
Yeah, okay, so we're just gonna do the.
should it turn hard blue or should it just hit the water blue?
That's why we start, right?
But then the blue goes away.
Well, that's the idea, because the blue will stay whenever we get to where we are, where we want to be. Where are we at on the 7? What do you guys say, 7 point what?
3.
All right,
8, 4.
so we're already over that. So it's bound to happen pretty quickly. Oof.
Sorry.
Mhm. So what you want to do is this. Here. So if we can get it so that it just drops, just like that. We can go like that. Get ready to stop it. Because at some point you gotta do both. Right? Oof. That's that. Stop it. There it is. How many drops went in after it turned blue though, Peter? 1 or 2? Oh, good. That's actually awesome.
Okay.
So that's right at the point.
And it's at
9.7, 1.8.
9.7 what?
9.79.
All right. Are you guys measuring from the bottom of it?
Yeah, I'm
So
confused.
it looks like 9.9 something. to me.
Yeah, not,
It's really close to the 10 on that.
yeah. Not, it looks like 9.99.
There we go.
Okay.
Right, we just have to make sure we do the same measurement each time.
Okay, but I'm confused because that's the final volume of the base, but we already found the final volume of the base.
Well, no, we didn't. We found what might be the final volume of the base. Their estimated volume was 7 something, right?
So
We found experimentally that it's more than that.
Okay, 7.84. So this was 7.84, and this
Well, no,
was
that's nothing.
the final volume.
This is the final volume of the base.
Oh, but this is the actual volume. I'm
No,
confused on the
The final,
difference.
well, we define the volume, the actual, we take this minus this, final minus initial. So we found out that their math is incorrect. It may be a problem with our pH meter, right?
Yeah. So we do 9.99 minus 0.19.
Yep. If you quit get rid of the 7.84. That 7.84 is an imaginary number that they got with
Okay. I'm
math,
just gonna
right?
write that about then.
There we go.
Okay.
This is all for experimental stuff.
Okay.
That was to give you an idea of about how much it would take.
Okay.
About 8. Well, we know it's going to be a little more than that, right?
So 9.99.
All right, we did titration.
Okay, so for trial number 1, the initial volume of the acid is 0.00, and then the initial volume of the base is 0.19, and then the final volume of the acid is 9.99, and the final volume of the base is also 9.99, and then we subtract the final volume minus the initial. So your actual volume should be 9.99, like for the base. Your actual volume should be 9.99 minus 0.19. And for that, I got 9.8. And then for the acid, it's just minus 0, so it'd be the same. Okay, let's do it.
It might go down to here,
Okay, that was stressful.
So then we take 23.78 minus 11.78. That tells
Okay,
us
so now what do we do? I never want to do that again. Ever. Okay. Yeah, pretty much. So let's get one more in. If we get one more in, that'll be happy. I'm still like scared again. So I should pour this out. Okay. But I don't need to clean it, right? Or should I? Yeah, right. Let's take that because it has a base in it.
So we're redoing the same
Well, don't pour any more in because you've got to use this or we're pouring it out by the end of this day. Right? And all of this, wait, this is all we have left is that. So hopefully we have enough for you to finish your trials after the other classes visit. Yeah.
Just for clarity, did you say that VB was 9.6, or what did you say VB was?
9.8. Because 9.99 minus 0.19 is 9.8. Okay. Is that the acid? Yeah, that's the acid. Okay.
What do you calculate?
So what do you mean by keep the volumes or like keep everything the same?
So now this is the initial volume of the next drop.
Okay. Okay. So I don't need to pour anything else.
Mm-mm.
Okay. So that's still 9.99. Okay. So for trial number 2, for unknown number 1, the initial volume of the base is still 9.99 because we start with the same one, if that makes sense. 9.99. And then the initial volume of the acid is 9.99, the same one. They're at the exact same spot. Okay, so then I take 10 milliliters.
Yeah, what'd you get?
This. Right?
So the BB is 9.89.
Yeah. No, wait. The VB for which one? Now we're on trial number 2.
Oh, I'm on 1.
For acid or base? 9.8.
Why not 8.9 if we're
I
subtracting?
don't know. That's what my calculator said. 9.99
When you
minus
did 9.99 minus 0.1.
0.19.
Oh, 0.19.
The initial volume is 0.19. Yeah.
Okay.
Yeah, it's HCl. So for every. Yep.
Okay, so we take another
No
10.
worries. This stuff is hard, and the only way I mean.
Wait, so
I could
we
tell
should
you
go
that
down
100
to
times
20
until you
or
actually
around
start to
20.
think about it and put it in the thing. It's not going to make any sense to you. So if I seem like I'm like just barking or whatever, it's just to make you stop and think a little bit. There's no other way. If I just sit there and say, "Oh yeah, that's the pH," just take, you know what I mean?
Okay,
Like,
I'm
even
gonna
if
pause it. Is it right there?
You guys plan on thinking.
It's like-
you're gonna have to process.
Right. So this is 0.19, like, or okay.
What's that? Yeah, remember HCl is a strong acid. So the molarity of a strong acid is equal to the hydrogen ion concentration, and vice versa.
So that was not two, right?
Yeah, you got the rest?
Right.
All right, I'm gonna put you back with them.
No, that's good.
I need to go back to
That's
the
like
main-
right on it. Sorry, I just don't, if I do it again, it's gonna go below. Okay,
Yeah, that's true. Thank you.
so for this one, I think we're gonna actually make the graph. So should we take the
You
page?
guys just go to the main room, because Gavin's the only one in there.
Do we have to take,
Oh, no, hi, Gavin. Okay.
What's up?
do we have to take the inverse log of the acid again to find like the pH and the inverse log?
Are you doing the pH trials?
Yeah,
So you just take the pH of that after you add the indicator.
okay.
So get ready to take the pH of that, and then he's gonna basically take the pH of that each time and yell it to them
Okay.
after 1 milliliter of base is added each time.
Well, how much time do we have? I don't want to do it.
Just try to get it done.
Okay.
Let's see.
I'm like, I'm around.
12:41. You've got 11 minutes.
Oh, maybe we should only do it for trial 3 then.
Okay. Yep, that works. So you got 11 minutes. I don't know if you haven't started the pH one yet. You may not want to. You may save that for tomorrow right when you come in.
2,
Okay, we might need.
3, 4. Okay.
So.
Okay. Okay. So do they need to find? We're gonna do the graph tomorrow because that takes a lot more time because that's when we take the pH every time we add like a milliliter of base into this, and we don't have enough time. So I'm just gonna do trial 2, like the one we did last time. But do you think we need to take the Mava over Ka again to find how much I need to drain? I think so.
I think we might because we have to use these numbers now.
Okay, yeah. So the molarity of everything is still the same. It's still 0.102 for the molarity of the acid and still 0.130 for the molarity of the base. So will you guys do that for me? And then the equations should be volume of the base equals molarity of the acid times volume of the acid times coefficient of the base divided by coefficient of the acid divided by molarity of the base. Here, I like set it up in here.
It's still.
This actually makes more sense this time. So you probably don't have time to do the pH thing, but you can get that titrated for sure. So we have these initials.
So should we know what the final volume is for the acid?
Oh yeah. Oh, sorry. Yeah. Sorry. Okay, so for that, it's 19. It should be. It looks like 19.98. Yeah. Okay, so for the final volume of the acid, it's 19.98. Because that's when we drained 10 milliliters of this and put it in. If that makes sense.
You said 19.98 is the volume of the acid?
The final volume of the acid, yes.
Okay. Is this trial 2 or trial 3?
This is trial 2.
So is the initial volume the final volume of the last one? Like,
Yeah.
okay.
Yeah.
I
Because
got
we left it. We don't add anymore. Sorry, go ahead.
15.68.
Okay. Will someone do it just to make sure?
Wait, how did we get more?
Because we're draining more.
To make it drop, I gotta go this way.
It goes from 0, like all the way at the top it's 0, and then all the way, and this is 10, and then this is 20.
Oh, okay.
So instead of you go the wrong way, you know which way you're going to top it, right?
Thank you, Adam.
So this one should be a better trial than before, because we now went up.
So is the actual volume 10 then, if we subtract them?
Wait, don't do that yet. We're just trying to. I just need the VB. because I need to start doing this. So I just need someone to check Raylan's work. Raylan, I did, and I got 15.67. Is that what you got?
That's what I got, but Ramaya is the one who first said something.
Crap. Sorry, I'm sorry.
I got 15.67 as well.
Okay. So when okay, 15.67.
Right? Pretty heavy stuff.
So when it gets to around 15.
Yeah, it's hard. It's hard to watch, but it's just like, oh, let's go. Oh, what? Yeah. It will eventually. How many milliliters do you put in there?
I put in, well, I put in, see the initial.
You're not double, right? It's gonna take at least nine. So let's keep going.
Right, it's supposed to be around 15.67 that I do it, and it's right at now it's at 15.6.
Probably not. Okay. Yeah, let's keep going.
Well, we got 2 out of the 3 graphs, or 2 out of the 3 things we're supposed to get done today.
Did you do the graph?
No, Gavin, got that, so you can do the graph. We spent a lot of time. We spent a lot of time.
Now it's at
So if it took 9.99 last time, we should be almost to 20 by the time this test goes.
okay, because the final volume of
Let's keep going. What about rings? 9.99 times 2.
The answer is 19.98.
So I'm thinking 19.98, depending on how good the first trial was. Get ready. Yep, stop. There we go, right? What do you think? Ready to do it tomorrow?
No.
This is more stressful by far.
More stressful than the cow.
I don't even know, man. I would say 19.97. Okay, so for the final volume of the base, it's 19.97. And then you subtract those to find the actual volumes. Oh man.
So for the initial volume, do we use the final volume of the first trial or the actual volume of the first trial?
Use the final volume to find the actual volume.
No. For the initial volume for this trial, do we use the final volume for the last trial or the actual volume from the last trial?
Final volume.
Okay, thank you.
Okay, let's clean up. Do we just dump all this?
Yeah, that's why you got to be careful whenever you pour your chemicals out each day, right? Know how much you're going to use.
And we use that.
We'll do that one tomorrow.
I think we use our
Cops should all be open.
Half of the lab already.
Did you guys figure things out?
All right, let's go.
Oh, no.
Good.
We drained them. Oh, that's true. You are.
I got for the VA I got 9.99 and for the VB I got 9.98.
Yeah, that's what I got.
What do you want? Oh.
Okay, you guys are good to go.
Thank you.
Bye.
Thank you.
Thanks.